Good afternoon. I welcome you to the session of IC engine gas turbine, and we will continue our discussion on the fuel ignition system. In fact, we have discussed about the different types of nozzle which are used for the compression ignition engine injection system. Then we have discussed about the limitation of the carburation system, and to overcome those limitation, SI engines are now equipped with fuel injection system, and we have discussed about the different types of fuel injection system for the SI engine. So, today we will see that as we have discussed, one of the important parts of the SI engine is the spark plug. So, spark plug is used to ignite the compressed charge for the SI engine, and we will see that what are the different components of the ignition system, and by using very 10 to 12 volt battery, how we can create how we can break the spark gap by creating huge voltage. So, today we will discuss about the ignition system. In fact, to be precise, we will be discussing about the battery ignition system. So, again, if we try to recall, we have discussed about different components of the SI engine. We have discussed about the SI engine carburation system, which is used to supply homogeneous as well as stoichiometric air fuel ratio. We have also discussed about the limitation of the carburation system, and of course, if we need to design modern carburetor, what are the aspects we need to consider. Then we have discussed about the SI engine injection system, considering different types of injection, different types of nozzles which are there, mechanically actuated, electronically controlled unit, and today we will see the ignition system, which is very important to ignite the charge which is being inducted during intake stroke. So, at the end of the compression stroke, we need to ignite the compressed charge, and how we can ignite the compressed charge using the ignition system. To be precise, battery ignition system, that we will discuss today. So, to start with, we will be drawing the schematic diagram, from where we will try to explain what are the different components and what are the objectives of different components, and then we will see how we can create huge how we can develop high voltage which is required to break the spark gap in the spark ignition engine. So, we will be discussing about spark ignition engine, and we will be discussing about the ignition system. So, as you have said that this ignition system is required to break the spark gap essentially by developing high voltage. So, if we try to recall that so this is the of course, we will have intake manifold, then we will have exhaust manifold. Now, air plus fuel, if it is carbureted, air plus fuel will come into the engine cylinder during intake stroke, and then this is the spark plug. So, this is the spark plug, right. So, piston will traverse between these two locations, that is top dead center and the bottom dead center. Now, if I draw the zoomed in view of this particular part, that is this is spark gap which is 1 to 1.5 millimeter, and this is high voltage terminal, and this is ground. So, voltage between the gap until reaches to 10 kilovolt to 20 kilovolt, nothing will happen. So, we need to develop high voltage, and the order of magnitude of that voltage will be 10 kilovolt, and until the voltage, rather the developed voltage reaches to 10 kilovolt, the nothing will happen. That means, to break the spark gap which is having 1 to 1.5 millimeter gap, we need to create very high voltage, and we have seen in most of the vehicle we use 10 kilovolt battery, we use 12 volt battery, 12 to 24 volt batteries. Now, using such small voltage, how we can create this huge voltage essentially to break the spark gap which is required to ignite the fuel. So, this 10 to 20 kilovolt is voltage is required to break the resistance of the spark gap. So, that is using such small voltage 12 voltage to 24 voltage, we need to develop 10 kilovolt essentially to break the resistance of the spark gap. Now, we would like to see the circuit, and the circuit which will be used, or which is used to step up the voltage from 12 volt to 10 kilovolt. Now, we will see the different components in the circuit, their objectives, their functions, essentially to step up the voltage from lower one to the highest one. So, now we will discuss about the schematic of the ignition system. So, this is ignition system. So, we will draw the schematic. And and then So, this is the schematic depiction of the ignition system. Now, I will try to label all the parts which you can see from the schematic, that is, this is battery. So, this is battery, that is 12 volt to 24 volt. This is ammeter which is used to measure the current. This is ignition switch. So, this is ignition switch. This is one resistance which is known as ballast resistance. Resistor, and this is ignition coil. Is very important for the ignition coil. This is capacitor. We will discuss the objective of different parts which we can see in the schematic. This is capacitor, and or in many books it is written condenser. This is breaker points. So, these are breaker point, and this is breaker cam. And this is two cylinder, spark plug, and this is known as distributor rotor. This is distributor which distribute the high voltage, and this is distributor rotor. And so, these are the different parts of the ignition system, and two cylinder spark plug, that is what we have seen in the previous schematic, that high voltage terminal. So, this is coming from that is the cylinder spark plug. Now, we need to explain the functions of every component in the schematic. So, we have battery that is used, as I said, small voltage which is used. Of course, we need to supply small voltage, and circuit will be used to step up the voltage from 12 volt to 10 kilovolt. Ammeter is there essential to measure the current, and ignition switch. So, we will write the objective of different parts. So, one is ignition switch, which connect or disconnect the ignition system. From the battery, so that the engine can be stopped or started, right. Then ballast resistors, the objective of the ballast resistor is that it is very important that an additional resistor that we are putting over here, objective is to regulates the primary current in order to increase life of the breaker contact point. We will discuss by how breaker contact points. Now, then of course, we have condenser, capacitor. Objective is to purpose is to reduce the arcing or arcs in the breaker point thereby increasing their life. And very important is the ignition coil, very important part is ignition coil, and the purpose of this coil is to step up the voltage from 12 volt to 10 kilovolt, of the order of 10 kilovolt, right. This is they are the and if I go back to the previous slide. So, we have ignition switch, we have understood, ballast resistor, ignition coil, breaker cam, and distributor rotor function is to distribute, of course. Okay, we can write the distributor, right. The name I am not going to write. So, why you are calling distributor? Because the name of the distributor comes from the fact that it is used to distribute high voltage among the rather through different cylinders, and that is why the name distributor is coming. So, the objective is it opens and closes the primary ignition circuit. Number 2 is distribute current in respective cylinders. In the engine, and finally distributor I am writing, and finally this distributor has mechanism which controls the point at which breaker points opens, thereby advancing stroke retarding the spark as required for the engine. So, these are the functions of different parts that we have labeled in the schematic. Now, we need to know how we can generate huge voltage using small voltage from the battery, which is of the order of 10 volt. So, using a voltage which is of the order of 10 volt, we can develop huge high voltage which is of the order of 10 kilovolt. So, to understand the mechanism behind this development of high voltage, to step up the high voltage from lower one to the higher one. Now, we need to know one thing, say rather I would explain by again drawing one schematic. Say we have this is phi t. So, we can write E 1 is N 1 d phi dt and E 2 is equal to N 2 d phi by dt. So, and what we can see that when I p, that is current, I p t, I can say I p I t, when current, when the current passes through the primary coil. So, this is the primary coil and this is the secondary coil. What will happen? So, when current passes through the primary coil, then passes through primary coil, it will produce magnetic flux, and this flux, that is phi t, when passes through the secondary coil, then an EMF E 2 is produced. So, that means we are allowing current to flow through the primary circuit. So, this is basically what is happening inside the ignition coil. To explain that, we have drawn this schematic. So, we know the voltage difference between this in the primary circuit, in the primary coil. So, if we now allow current to flow by switching on the switch. So, if we go back to my previous slide, if I just switch on the ignition switch, then breaker point is in contact, breaker points are closed, and if we now connect the ignition switch, then the circuit will be connected, and if the voltage is Vt, that is time dependent, a current will flow through the primary circuit when current is flowing through the primary circuit or primary coil, magnetic flux will be produced, and then those magnetic flux will passes through the secondary coil, and then E2 is produced in the secondary coil. Now, this E2 when passes through the I mean again when it passes through the primary coil, this flux, then a back EMF will be developed, and that will try to oppose the current in the primary circuit. So, what we can say, the current is, if we switch on the ignition, if we connect ignition switch, or if we on the ignition switch and the breaker points are closed, then current will flow through the primary coil, magnetic flux will develop or produced. That magnetic flux when passes through the secondary coil, and EMF will be developed in the secondary coil. Now, again the flux when passes through the primary coil, then a back EMF will produce, and that will try to oppose the primary current that is flowing through the primary coil. So, here E2 is the induced EMF and E1 is the back EMF. So, electromotive force. Now, the back EMF will try to oppose the current in the primary circuit. As a result, what will happen if we try to draw the I current, which is function of time versus time, then it will be like this, and it will, so it is not straight line, rather it will be a curve, and we have understood that it will take some time for the development. That means, the back EMF will try to oppose the primary current to flow, and as a result it will take some time for the development. So, initially we have understood that of course N2 will be greater than N1, N2 is greater than N1, then we can say that back EMF that will be developed will be I mean that will try to oppose the primary current. Now, initially we have assumed that breaker points are closed. So, now if we try to go back to the circuit, what will happen? Now, we can see that if we now breaker points are closed, we are switching on the ignition switch, then current will flow into the, so this is primary, so this is primary coil, and this is the secondary coil. Right, and initially it is assumed that the breaker points are closed, what we can see from the schematic, and when the when and current will flow. Now, when the breaker points are open, then the current will try to be 0 in a very short period of time. That means, what we have seen from this diagram, the current will try to fall for a short period of time, it will fall like this, and then we will discuss that it will start oscillating like this. So, within a short period of time, I mean very small time, it will be 0, that we will see, we will discuss. So, this is very small time. So, within the small time, the moment when breaker points open, the current will try to be 0, the flow of current will try to be 0 in a very small time. That means, there will be a sudden change within a very small, sudden change in the slope within a very small time period. So, that is what we have understood from this schematic. Now, question is, we have to explain what is happening, and also we will explain, here we have explained the oscillation, we have shown the current, the profile which is having kind of oscillations. Now, we will discuss why these oscillations are coming in the profile towards the end of this discussion. So, if we now look at the schematic carefully, what we can see, if the breaker points are closed, if we switch on the ignition ignition circuit, then a current will flow into the primary coil. When currents are flowing in the primary coil, we have understood from the second schematic that there will be a induced current in the secondary coil, but the induced voltage is so low that, so because of this flow of current through the primary coil, an EMF will be developed in the secondary coil, but that EMF is not large to break the spark gap that is required. We have understood that at least 10 to 20 kilovolt is required to break the resistance of the spark gap. So, the EMF which is developed in the secondary coil, that won't be able to develop that that won't be able to break the spark gap that is required, I mean voltage which is required to break the spark gap. So, what is done now, if the breaker points are, I mean when the breaker points are closed, it will the current will try to charge the capacitor or condenser, and if the moment when breaker points opens, then current will tend to be 0. So, that is what we have understood. Now, when the cam, that is, now if we look at the distributor side, that when the cam on the distributor shaft, that is distributor rotor, when the cam on the distributor shaft opens the contact points. So, when these contact points open, so breaker points are closed, current is flowing through the primary circuit, current will try to charge the capacitor. So, capacitor acts, so capacitor which acts as a reservoir, which acts as a reservoir. Now, what will happen when the and we have understood that the small EMF that is developed in the secondary coil, that won't be able to break the spark gap. Now, what will happen if the distributor cam I mean on the in the distributor shaft opens the contact point, what will happen? The magnetic flux, we have understood that the magnetic flux will be developed. So, when the cam on the distributor shaft opens the contact point, then what will happen? So, I am writing here writing. So, I can write the ignition system, ignition circuit, so when the cam on the distributor shaft or distributor rotor opens the contact point. We have seen that when the cam, rather if we go back to the previous slide, what we can see, the cam, the distributor rotor is in contact with the this small point. Now, when the distributor rotor opens the contact point, what will happen? So, the magnetic flux that is developed in the ignition coil. So, we have understood that when current is flowing through the primary circuit, breaker points are closed, there will be a flow of current through the primary circuit, and because of that there will be the magnetic flux developed, and now an EMF will be developed in the secondary coil, but that EMF is not sufficient to break the spark gap. Now, when the distributor rotor is rotating and it opens the contact point, the magnetic flux in the ignition coil will try to collapse. So, I am writing, so that means contact points, the magnetic field collapses and as a result an induced current from the collapsing magnetic field flows in the same direction of the primary of the current in the primary circuit. Or I can say same direction of the primary circuit as the battery current. So, battery current is flowing through the primary circuit in a direction, and the induced current also will try to flow in the same direction. Now, and charges the condenser and charges the condenser, and which acts like a reservoir. Now, the moment when the breaker the distributor rotor opens the contact point, because of rapid collapsing of magnetic field, a high voltage will be developed in the secondary unit, and the voltage is about I can say sorry, what I said, that because of the rapid collapsing of the magnetic field, a voltage will be developed in the primary circuit, and that is also very high, of the order of 250 volt, but this also leads to development of a extensive rise in voltage in the secondary circuit, that is of the order of a kilovolt, right. So, what we have understood? So, if I go to the circuit, we can say that when the breaker points, distributor rotor opens the contact points, because of the magnetic flux, magnetic field in the ignition coil will collapse. Because of the sudden collapsing of the magnetic field, an EMF or voltage will be developed in the primary circuit. I can say the high voltage, which is of the order of 250 volt. Now, this high voltage in the primary coil also leads to this collapsing of the magnetic field also leads to development of even higher voltage in the secondary coil, which is of the order of 10 to 25 kilovolt, and that voltage, since the that voltage, now when the distributor rotor is coming to the next point, the voltage will now go to the spark plug, which is placed in a particular cylinder of an engine, and then we can ignite the charged by essentially by breaking the spark gap. So, now I can say so this is the ignition system. So, if we try to summarize what we have understood, that if we switch on the ignition coil primary circuit by switching on making on the ignition switch, now and breaker points are closed, then a battery current will flow into the primary coil, and the current will try to charge the condenser, and that is what the objective of the condenser is. Now, when a primary current is flowing through the primary, battery current is flowing through the primary coil, there will be an induced EMF in the secondary coil. That is what we have understood from the second schematic here, and this EMF is not sufficient to break the gap, the spark gap of the spark plug. Now, what is happening? Breaker points are remaining closed. What is done? The distributor rotor, initially it was in contact with one point, now it opens. So, when the distributor rotor opens the contacts, what will happen? There will be sudden collapsing of the magnetic field that is developed in the secondary coil. Because of this sudden collapsing of the magnetic field in the secondary coil, in the ignition coil, a voltage will be developed in the primary coil, rather I can say high voltage, which is of the order of 250 volt, and the collapsing also leads to development of a huge voltage in the secondary coil, that is of the which is of the order of 10 to 20 kilovolt. Now, when and because of that, what will happen, as I said, that a current will flow into the through the primary coil, which is in the direction of the battery current, and it will try to charge the condenser. But the condenser has a limit. So, as the primary current is also trying to charge the condenser, and the current which is being developed because of this high voltage in the primary coil, that also will try to develop current, and that current will flow in the same direction as the battery current is flowing into the primary coil, and it will charge the condenser. After certain time, the condenser the condenser charging is complete, then there will be backflow of the current from the through the primary coil, and because of what we have seen, the oscillations will be appearing in the current versus time diagram, and that is why these oscillations are coming, we have indicated. So, if we now write that, so we have understood that using small voltage battery voltage, that is of the order of 12 volt, using this circuit we can create a voltage which is 10 of the order of 10 kilovolt, and this voltage is good enough to break the spark gap in the spark plug, and ultimately we can ignite the charge in the cylinder. And if we now go back to the first schematic, you can see the breaker points, the distributor rotor rotates, and when it in contact with the a particular point, then again there will be as it rotates through the in the distributor, it will try to create that high voltage, and that connection will be that will be supplied to the cylinder spark plug of the engines. So, now if I write it, I can write that. So, what I can write, as soon as sufficient secondary voltage is built up, to overcome the resistance spark plug, spark gap, I can say spark gap, the ignition of the combustible charge in the cylinder takes place. But also you need to know that due to, rather I can say that the induced current in the primary coil flows in the same direction as it did before, the breaker points opened and charges the condenser. So, what I would like to say that when the breaker points are closed, battery current will flow and it will charge the condenser. In a similar way, the induced current in the primary circuit also will try to charge the condenser as it did before when the battery current is flowing through the primary circuit. So, this is the case. Now, what will happen? So, I can say that I can write. So, now condenser potential will increase and finally stops the flow of current in the primary circuit. And then rapidly backfires or discharges again through the primary coil, but in the opposite direction. This rapid discharge of condenser produces directional oscillations in the current flow in the primary circuit of the primary circuit. So, what we have understood? We have understood that, to summarize today's discussion, that this ignition system, this is battery ignition system, is used to produce the spark in the spark plug, and if we need to produce the spark in a spark plug, that is what we have understood in the beginning of this class, that we need to develop high voltage, and that high voltage which is required to break the gap, rather the resistance of the spark gap is 10 kilovolt. Now, using the schematic depiction where we have seen that there are different parts, and we have understood the objective of different parts, that how we can develop high voltage using a small battery that is having voltage 12 volt to 24 volt. Now, this small battery is used to create, rather that means we can say, using this ignition circuit and this battery which is having voltage 12 volt, we can create the high voltage, and by how we can create the ignition which is required to charge the, rather to initiate combustion in the engine cylinder. And what we have understood, that when breaker points are closed, if we switch on the ignition switch, then a battery current will flow in the primary circuit. When a primary current is flowing through the when the current is flowing through the primary coil, it will charge the condenser because breaker points are closed, and because of the flow of current through the primary coil, a voltage will be induced in the secondary coil, but that voltage is not sufficient to break the gap in the secondary in the spark plug. Now, what is done? The distributor rotor, initially it was in contact with the one terminal. Now, when it the contact opens, then there the magnetic flux, when that means when current is flowing through the primary coil, magnetic field will be developed in the ignition coil, and as a result we will get an induced EMF in the secondary coil, but that induced EMF is not good enough, is not sufficient to ignite the combustible mixture in the cylinder by breaking the spark gap. Now, when the distributor rotor contacts open, the magnetic field in the ignition coil collapses. So, because of this sudden collapsing of the ignition magnetic field, and EMF is developed in the primary circuit in the primary coil, and that is of the order of 250 volt, and also the sudden collapsing of the magnetic field leads to development of a huge voltage that is of the order of 10 to 25 kilovolt in the secondary coil, and immediately when the rotor is coming to the next terminal point, that voltage that is high terminal that voltage is used to break the gap of the spark plug, and we can ignite the fuel air mixture in a particular cylinder. What is happening when this EMF is developed in the primary circuit because of the sudden collapsing of the magnetic field? Again a current will flow, the induced current, and because of this induced EMF, current will flow in the primary circuit, and that is induced current of the collapsing magnetic field, but the current will flow in the same direction as the battery current is flowing through the primary coil, and it will charge the condenser. So, condenser is getting continuously charged, but a time will come the sufficient voltage is built up, that is what I have written. So, the condenser potential will increase. So, condenser is getting charged continuously, condenser potential will increase and finally stop the flow of current. So, and that is what we can see from the diagram, that finally stop the flow of current in the primary coil. Not only that, we have written that then again rapidly discharge through the primary coil, because condenser is completely charged, it will stop flowing current, it will rapidly discharge in the but the discharging will take place in the opposite direction to the primary current. Now, the rapid discharge of the condenser produces the directional oscillation. So, it will now discharge, again it will receive and discharge, and it will leads to directional oscillation in the current flow of the primary circuit, and that is represented by this diagram. That is what we have seen. So, we have understood that using this circuit, that is battery operated ignition circuit, ignition system, we can produce sufficient voltage which is required to break the gap of a spark plug, and we can ignite the combustible mixture in the engine cylinder, and we can complete this combustion process. So, with this I stop my discussion today, and we will continue our discussion in next class. Thank you.